Hello guys, how are you? Welcome to the Sushant method. In today's weekly tutorial, we are going to talk about quantum computing, the digital superpower of the future. So guys, in our previous one of the tutorials for digital trends, we discussed briefly about quantum computing, and today I'm going to explain it in more details to you guys. I hope it will be a very useful tutorial and keep watching until the end. And before we start, if you haven't subscribed to my channel, the Sushant Method yet, please do subscribe, like my videos, and share the content with your peers, friends, families if you find it useful. Okay, so let's begin the today's tutorial. Okay, so as I said, today's topic is quantum computing, the digital superpower of the future. Explain. So, what is the agenda for today's topic? So today we are diving into one of the most mind-bending and powerful digital trends shaping our future, quantum computing. So what is it? Why are tech giants like Google or IBM are racing for it? And how will it change our lives together and forever? Let's find out. So this is what quantum computing in overall, which I shared earlier. And today's agenda is we'll discuss what is quantum computing, why is quantum computing so important, sorry, real world applications, who is leading the race, challenges ahead, and what's next, and the conclusion. Okay, let's see the first one. What is quantum computing? The classical computer versus quantum computer. Okay, so in classical computer, the background calculation that happens in bits, which is 0 or 1, binary. Okay, so 0 means nothing, 1 means yes. So quantum computers use qubits instead of normal bit structure like classical computers. They can be 0, 1, or both at the same time. Okay, it's called superposition. So uh, these are the couple of example you can see. Imagine spinning coins instead of heads or tails. Okay, that's how qubits work. In heads or tails, you have binary. Either you will win or you will lose. That is 0 or 1. But in quantum computing, it's you know, no win or loss. It's tie, tie match. So just for fun, but this is what it works simultaneously. Okay. So the two superpowers in quantum computing: superposition allows multiple calculations simultaneously. Example: two separate applications running simultaneously on your computer. So you are browsing your one of the website, and at the same time some calculation or some music is playing in the background. That is called superposition. That is possible in today's quantum computers. Entanglement. So qubits, what they do, qubits are mysteriously linked. Changing one affects the other instantly. For example, again, two applications entangled, I mean they are going hand in hand with each other for, like shared Excel or Word file. You update one shared file. Okay, so if you are working in corporate, you might have one file which everyone in the team, okay, they update, and it is in the shared drive. So one from one computer it is updated, it gets updated for everyone. Okay, it's not that everyone has to do their. So this is how it works. At one computer will get updated for another person when open from other computer. So this is called entanglement. Okay, and superposition is quite easy. It is like two tasks coming, running simultaneously, concurrently, like music and your browsing. Very simple example. So why is quantum computing so important? So As we do more and more things simultaneously, speed increases, speed like never before. Okay, can solve in seconds what would have taken millions of years on classical computers. So you see the example or the scale I have shown here. On the left side, you see types of scaling, classical algorithm with exponential runtime and quantum algorithm with polynomial runtime. So, for example, if something happens uh, in 10 seconds, 1 second, let me try to explain this to you. Okay, so you see small tasks like 10 seconds may take happen 1 minute, 2 minutes, but something like 330 years, quantum computers can do it just in 10 minutes, or 3,300 like years, like long time, something which you thought in classic computers may take ages to happen, but that is possible in just 11 minutes now in quantum computers. Okay, so this is just like trying to show the difference. Okay, so in reality, in multiple applications, these numbers can vary. So which are the new frontiers? Example, cryptography. Okay, so cryptography means uh, you know some languages, or the communication happens in the backend, that happens in crypto language. It's not that one who who is sending the data, they modify that into crypto language, and the other at other end, the receiver can only understand that. It is called cryptography. So it makes your communication very secure, so such that someone tries to hack in between, they won't be able to understand what it is mean. What does it mean? Because it only the sender and receiver understand that crypto language. So that is called crypto encryption in seconds. AI and ML. AI means artificial intelligence, as we know, and ML is machine learning. Quantum speeds up training and pattern recognition. We'll discuss that in more detail. Climate modeling, accurate predictions using quantum simulations. Okay, the weather predictions kind of. Finance, portfolio optimization and fraud detection. So it is all in the speed, and more accuracy because of the entanglement and superposition principles, two principles we discussed on previous slide. Okay, let's see some real world applications. Uh, as we saw in the previous slide, artificial intelligence. So machine intelligence relies on experience based learning. Okay, so as you might have seen on chat gpt, it saves your data, it saves your conversation. So next time if you chat and you ask some question to chat gpt, it takes reference from the previous chat and gets a gist of it, what you're trying to ask, and it improves the communication between the AI and the human. Okay, that is called experience based learning. Data sets improve accuracy of AI. AI depends on evaluating billions of data points at the same time. So ChatGPT everyday example, it's not like Google. When you Google something, you get like hundreds to thousand results, and you don't have time to go through each. But the AI, what it does bring all results together and brings the answer, direct answer to you, what you want to hear or what is very close to that, making it suitable for quantum computing. It will be more efficient for some models. So you see here, as we discussed, deep learning, natural language processing, it is called NLP, computer vision, cognitive computing, and machine learning. These are all part of artificial intelligence. Okay. Second real world example, drug and vaccine discovery. Quantum computing can simulate complex molecular interaction, accelerating drug discovery and development. So guys, when COVID happened, you might have seen across all countries, starting from Pfizer in the US, or vaccine provided by China, or Covishield, or the other vaccines provided by India, Russia, everywhere in the UK or Europe. All vaccines were ready in just span of 6 to 1 year. In ideal world, vaccines do take time about 10 years at least. Did we have that time during COVID? No, we did not. So quantum computing helped a lot. They did a lot of human work and simultaneously and with the precision and awesome speed. Okay. So this is what is happening in drug and vaccine discovery. So that is why see many diseases are being investigated deeply like cancer, HIV, human immunovirus, AIDS, or any other deadly diseases. And we are seeing some solutions or some vaccines or the drugs are being produced, and we may see them very soon in the market just because of quantum computing. Okay, so that huge impact it has. Marketing and advertising. So the guys or girls who are in marketing or have advertising background, they might have used called programmatic advertising. Okay, so target the right audience digitally using programmatic advertising where there is a large and complex calculation of data available for how customers are browsing, what are their choices, what they like, what they dislike, and accordingly target the consumer. For example, someone wants like sports cars or something related to sports equipments. Okay, they have browsed those websites a lot, and when we are selling some sports equipments, we have the data. Okay, so these are the set of customers in particular geography, in particular age bracket, gender, and all these categories. So accordingly, if we do it manually, it will take hell lot of time. Okay, and it is not that possible, and the scaling of that marketing won't be easy. But using the quantum computing like programmatic advertisement, you just create your campaign, you put your imagery, and this tool does the wonder for you and shows the ad to the right consumers. Then if they click it, they don't click it, it's the different ball game. But at least the probability of getting the clicks and eventually sale increases. Okay, so that's what example I've given. Google's quantum computer Sycamore demonstrated quantum supremacy by performing a complex calculation in 200 seconds only that would have taken classical computers thousands of years. One more example, supply chain. If you don't have supply chain, world will not run. Okay, we won't be able to ship anything, we won't be able to ships won't be able to run, we will not get fuel, we will not get, the export import will stop overall. Okay, so there are two giants in this field, THL and Volkswagen. They started using quantum algorithms to route vehicles more efficiently. So quantum computing does everything about giving the directions, the logistic part, okay, shipping part, and everything involved in that process. Okay, so you can see this video more and more details, so you will understand. So who is leading the race? Who are these tech giants? Google. You see, Mr. Sundar Pichai in the Google lab, the quantum computer. This is what the quantum computer is, multi-layered. And yeah, quantum supremacy claim in 2019. The programmatic advertising I was talking about, it is also Google's model for marketing and advertising. Okay, IBM building 1,000+ qubit machines. Microsoft, Intel, Amazon, all these giant companies, all are investing billions of US dollars in quantum computing for more and more innovation. Startups like Rigetti, IonQ, D-Wave are exploring different quantum tech like superconductors and ion traps. Governments, obviously China, US, European Union investing in national quantum strategies. Okay, the leading countries, all the major economies. Okay, so what are the challenges ahead? Every technology brings new challenges. Okay, so nothing will come so easily. What are the challenges? Okay, first one, fragile qubits need ultra cold environments near absolute zero. So it's not something you can do it anywhere. You need to create that environment. Your the geographical environment be suitable, may not be suitable, or you can create something which is not real. Okay, near, so something like that, a lab, which physical lab, um, errors from noise, vibration, magnetic fields, all these factors, scientific factors, they do, you know, they do affect this. That's why they call fragile qubits. Error correction. Massive qubit overhead required to correct a single logical operation. So as I said, there are things happen simultaneously. Big quantum computing. One error, one error can destroy everything, and that single logical operation. Okay, so you understand. So if it happens perfectly as it was planned, it can make wonders. But what if it doesn't? Okay, it can destroy everything. One problem. So if I give you examples, like when the satellites are, you know, the big space agencies like ISRO, NASA, they leave satellites in the space. Okay, what happens? It has micro computing, quantum computing calculations. What if one calculation goes wrong? Your billions of dollars may go wasted. Not just money, it's efforts, scientists' efforts. Okay, so this error correction can cause, uh, you know, heavy um, backlogs for the still early days. It's a lot of innovation is yet to be done. Current machines are noisy, intermediate scale quantum, which is called NISQ. Because it's new and there are a lot of challenges, of course, then it is not so easy to scale. Scalability. Building stable system with millions of qubits is still years away. Okay. But I assume we will be there once. One day we will be there. Let's hope. What's new and what how we can conclude this tutorial for today. So we are hoping, humans are hoping by 2030, we could see commercial quantum advantage. Industries will integrate quantum in hybrid systems with classical machines. We don't have to get rid of classical computers. So we have AI now. Have we got rid of Google? No, we need both. Okay. So let's see how we can integrate that quantum hybrid system with classical machines. Quantum internet is also coming. Ultra secure communication using NTech. The security is one of the biggest issue. Okay. So how we can conclude? So you can say quantum computing isn't just a new kind of computer, it's a new way of thinking about reality itself. It's not here to replace classical computers. No, no new technology replaces the old one unless it becomes absolute. Like um, USB replace compact disk they replace the floppy drives, and now we have something more than USB. We don't need USBs, right? We have more machines coming up. So like that. So it depends. But generally the major technology won't get replaced. But to unlock problems we could not even attempt before. Okay, so something for new, creating new opportunities, scalability, more speed, more precision. Okay, less errors, achieving the Six Sigma level 99.999%. Yeah. We are standing at the age of quantum era. In 10 years, your job, health, and even daily life might be touched by quantum technology. Guys, like and share and subscribe to the Sushant method. I hope you enjoy today's tutorial about quantum computing. We'll come up with more and more technological and geopolitical pot- videos in upcoming future. So keep watching the Sushant Meta. Thank you. Bye.